Hello, welcome to another episode. In this episode, we are going to talk about Newton laws of universal gravitation. So that is what we are going to break down in this episode. So before that, could you please like, subscribe, and then share this video with your friend? That will help me a lot. So let's proceed with today's session. Newton laws of universal gravitation is stated that for every object with a mass m, okay, with a mass m attract every object with another mass. That is what we call it in Newton universal gravitational laws. Okay, meaning that let's say if you are running or if you are walking, meaning that you are applying or you did apply an attraction force on earth as well as earth apply attraction force on you. Basically every object or every object in the universe with a mass m can be attract each other. Okay, that is what we call it in Newton laws of universal gravitation. Okay, you can take a particle as well, meaning that if a particle with the mass m can attract a particle m with another mass. That is also you can take as well. Let's say we have a particle or we have a mass m. We have an object with a mass m as well as this is a mass, another object with a mass m2, and then the separation between both mass m as well as a mass m1 and m2 is r. Okay, let's say this is r. Sorry about that, guys. So let's say this is an R, and then the objects one or mass. Basically, this is an object or a particle, or we can take it like I said, a particle or an object. So object one attract or apply attraction force on object two. Object two apply attraction force on object uh, M1. Okay, that is what we call it a Newton laws of universal gravitational Newton laws of universal gravitation. So to find out the Newton laws of universal gravitation, we can use this equation or this formula. So this is a force. You can see this is a gravitational force between two two objects. Basically, is an object. Okay, we call it. This is object. Okay, this is an object between two mass or two particle or two object. Okay, that is, and then I just wanted to let you know that the force of universal gravitational force is directly proportional with the mass of two particle or mass of the two particle, as well as inversely proportional to the separation between two mass. That is basically a basic definition as well. So like I said, you can use this formula to find out the universal gravitational force. And then this is a gravitational constant. This is a gravitational or universal gravitational constant, which is equal to basically 6.674 multiplied with 10 raised to 11 Newton meter square per kilogram square. And then this is a mass. Okay, this is a mass m1 and m2 of an object or two objects. This is a separation between m1 and m2 is a distance. That is all about universal or Newton laws of universal gravitational force. Okay, now, yep, if you have any question, let me know in the comment section. I'm happy to reply for you guys. And then, like I said, could you please like and then subscribe this video, as well as you can share with your friend. So let's proceed with just a quick example. So it says that two identical isolated particle uh, with a mass of 2 kilogram, and then the separation between two of these two mass is the distance between is like 30 centimeter, and then was a magnitude of gravitational force exerted one particle on the other particle. Okay, now to find out this example was basically it's an exercise from I think from grade 11. So I mean grade 12. Okay, it's not from 11, it's grade 12. So you can find out this exercise in grade 12 physics book. Okay, so we need to find out the given term. So we have, okay, we have gravitational constant, okay, which is universal gravitational constant, which is G, okay. G is equal, so let me change my marker. I'm sorry guys. So G is equal to 6.674 multiplied with 10 raised to minus 11 or negative 11 Newton meter square per kilogram square. Okay, and then we have M1 as well as M2, right, which is equal to basically 2 kilogram, right, and then we have a distance or the separation between M1 and M2, which is equal to 30 centimeter, right? Then which is equal to basically you need to convert to the standard or SI unit, which is 3 meter. Okay, those are a given parameter, and then the required term is what? The universal gravitational force or the magnitude of a gravitational force, right? Which is equal to, you can say question mark, and you can say a solution. To find out, like I said, a magnitude of gravitational force, we can use this equation, which is basically F is equal to universal gravitational force universal gravitational constant multiplied with m1 multiplied with m2 upon r square. Okay, like I said, this force is directly proportional with this two mass or the particle given mass of an object, as well as inversely proportional with uh, the separation between two mass. Okay, now you can plug this term over here, which is equal to G is 6.74 what Newton meter square upon kg or kilogram square multiplied no, it's supposed to be, right? I'm sorry about that, guys. So multiplied with 1, I mean 10 raised to 11, right? 10 raised to 11 Newton meter square kilogram square, right? Kilogram square multiplied with m1 is 4, right? This is multiplication sign. M1 is 4, I mean 2, right? 2 kilogram multiplied with 2 kilogram, okay? Upon 0.3 the whole square, that is it. And then force is equal to, this guy is 4, right? This term is 4, this guy is, okay, let me rewrite over here, 6.74 multiplied with 10 raised to minus Newton m square and then kg square, right? Multiplied with 4 kg square, okay? Or kilogram square. So over 0.9 meter square basically, right? This guy is cancelled with this guy. You can cancel this guy with this guy. Don't. Then you're left with a Newton, and then you can multiply this guy with this guy, and then divide, or yeah, you can multiply this guy with this guy, and then you can divide it for 0.9, and then you will get universal gravitational force is equal to 2.97 multiplied with minus multiplied with 10 raised to 9 Newton. So that is it for this exercise. I'm sorry about that. There is a given term over here, guys. So this is a given. So yep, that is it for this episode. Like I said before, let me know if you have any question in this definition. I mean, in this explanation as well as in the exercise. I'm happy to reply for you guys. Yep, that is all for today. Like I said, could you please like, share, and then subscribe this video if you are TikTok, you can follow, like, and then share this video. If you are in YouTube, you can subscribe, like, and then share this video. That will help me a lot. So yeah, that is all for today, and then have a good day. Thanks so much. Goodbye.